Let us, in this presentation, we discuss about the Elasticsearch. Let us see first the overview of this video. That is what we are going to learn in this video. So first of all, we will be discussing about Elasticsearch. That is what exactly Elasticsearch is. And after that, we will see different components of Elasticsearch. And at the end, we will see how these components are interconnected and how they works to build up the entire Elasticsearch architecture. Okay, let us begin. So Elasticsearch is mainly a search engine and it is distributed in nature, and it offers a number of features by which you can get the data analytics as well. So first let us see how Elasticsearch works. So suppose here we have this Elasticsearch instance and we can input data from different sources. Maybe from a database we are inputting data into Elasticsearch, or maybe some log data we are inputting, or maybe there are some third-party microservice by which we are inserting data into Elasticsearch. So Elasticsearch, what does it do? It takes those data from different sources and do analyze and index by using the most appropriate data structure, and the data structures depends upon the data type. It uses the most appropriate data structure based on the data type. It uses inverted index, binary search tree, BKD trees, etc. And after doing this, Elasticsearch provides a RESTful interface, very simple RESTful API interface by which user can interact with Elasticsearch. So this is the outer view of Elasticsearch. Now we will focus on some Elasticsearch features, some very good features which offered by Elasticsearch. So first of all, what comes, that is the full text search. So Elasticsearch is mainly so much popular because of the full text search option. Let us take an example of full text search and see what exactly this is. Suppose we are storing the book information in our database. Suppose a book name is there. The book name is A Brief History of Time, and user in the search box writes something like this: time history brief. That is, the terms are not in exact order what exists in the book name. In spite of, Elasticsearch finds the exact result and displays it by matching each and every term. But the same thing is difficult to achieve if you are using RDBMS or any other NoSQL databases. Let us see another feature, that is relevancy. Suppose we are doing a search query in our website and we always be wanting to display the most relevant item at the top. Suppose based on some input query, Elasticsearch finds hundreds of documents. Out of those 100 documents, we will always be wanting to display the most relevant items at the top. So for this, Elasticsearch generates some score that is called relevancy score. Okay, and the score signifies how relevant an item is based on that input query. That is, the most relevant item gets the highest score, and Elasticsearch by default shows the item which has the highest score. That is, the result is always sorted by the score. That is, the highest score item will be displayed at the top, and this is the default feature of Elasticsearch. So this is very useful. Next, we see another important feature, that is typo in query. Suppose user types wrong spelling in the search box, and it happens very often in real life cases. Let us take an example here. In our case, suppose user types something like this: brief history. Okay, still Elasticsearch is able to find those the correct item by using some approximation algorithm like fuzzy search or phonetic search. So this is also a very good feature, and you do not need to do any special configuration to achieve this. Elasticsearch supports all these features by default. These are the very simple and primary features of Elasticsearch. Now let us move on. Let us take another thing, a geospatial search. This is also a very interesting feature. Suppose you are creating a hotel search application, and Elasticsearch supports a data type called geopoint. Like other data type, there are types like integer, float, and here the another data type is geopoint. Here Elasticsearch takes values like this, latitude and longitude, in when there is a geopoint data type. So here, if we are creating a hotel search application and we store the coordinates of each and every hotel location, and when user is doing search based on user current location, we can display the hotels to the user sorted by geographical distance. That is, the nearest items will be displayed first, and this thing also can be achieved very easily without any special configuration in Elasticsearch. Now let us see Elasticsearch. It's very highly scalable. Elasticsearch is distributed in nature, and what happens in case of distributed system, that the data is not centralized in one place. Instead, data is distributed among multiple systems, and this scalability can be achieved very easily in Elasticsearch. Maybe when we are as a startup, we have only one machine there, and though it is distributed, we are using only single machine. But when our business needs grows, the number of requests per second or minute grows, then we will be needed multiple machines there, and we can add more and more machines as per requirement without any hassles and difficulty. Now Elasticsearch is nearly real time. That is, whenever we are putting data into Elasticsearch from different sources, the data is instantly available for searching to the user. That is, for the magical things what Elasticsearch does, that is the analysis and the indexing. For those things, Elasticsearch does not take much time. Whenever you put data into Elasticsearch, it is instantly available for searching. Now let us see another feature that is called analytics. Elasticsearch has some strong aggregation queries, and these queries are also very simple in nature, and by using these queries you can get the trend or pattern of the data you are storing in Elasticsearch. And there are tools like UNL by which you can visualize those data as a graph. So Elasticsearch is called an analytics engine as well. So these are some of the very good features offered by Elasticsearch. Now, before we move to the hands-on experience of Elasticsearch, let us see the different components of Elasticsearch. And the major components of Elasticsearch are document, index, sort, node, and cluster. We'll discuss about all these components and see how they are interrelated, and by all of these components the Elasticsearch architecture are developed. So first of all, let us discuss about the document. A document is similar like a row in a table in RDBMS. In RDBMS table, the data is stored as a columnar fashion, that is, one new row is inserted per every new entry. But here in case of Elasticsearch, data is stored as a JSON object instead of row column fashion. Here in case of Elasticsearch, data is stored at JavaScript object notation. That is, here we have one document, and here this is another document, and each and every document has the field name like book name, author, category, etc. Okay, this is just simple. A document is similar like the row of a table in RDBMS. Now let us see what exactly an index is. An index is similar like a table in RDBMS where similar kinds of data are stored. Let us see the example of an index. Here we have the index name, that is the books. We are storing books information, so we have given the index name as books, and there are fields, author, book name, and category, and each and every of these fields have data type as text here, but you can define this data type as integer, float, IP address, geopoint, etc., whatever you need it. All the data types are supported by Elasticsearch. Another thing is Elasticsearch is schemaless. What happens in case of RDBMS? It is mandatory for you to define all the fields before you insert data in RDBMS table. But here in case of Elasticsearch, defining fields is not mandatory before inserting data. If you do not define a field and attempting to insert data, Elasticsearch automatically will define that field based on the data type you are inserting. Next, let's move to the another component that is called node. A node is just a virtual or physical machine. That's a computer with some computing resources, maybe a processor, memory and storage. And that is a computer and where Elasticsearch is installed. A node is just a physical or virtual machine where Elasticsearch is installed, and it is recommended to install only one instance of Elasticsearch in a computer. And when our business needs grows, we will be needed more and more nodes to add in our system. So we will add new machines with new Elasticsearch installed there. One question comes here: whenever there are multiple nodes, we need all of these nodes to stay connected and synchronized. So to keep them connected and synchronized, there must be some rules. So for that we need another new component of Elasticsearch that's called a cluster. So a cluster is just a collection of nodes with some properties there. First of all, they must be connected via LAN, and in config/elasticsearch.yml there needs to have some configuration with the cluster name and some IP bindings, and these configurations are very simple and straightforward. And if we need more and more nodes to add, we'll just make it connected to the LAN and install their Elasticsearch and do some configuration, and our new node will be added into that cluster. And this clustering gives a number of advantages. Suppose when we are in production, a particular node is crashed, and still our system will remain operational because the other nodes are still alive. They will keep the system operational. So one question comes here: as there are multiple nodes there, so there must be some rule by which the data is distributed among these nodes. So for this, another component comes into picture that is called a shard. Let's see what exactly a shard is. Suppose we have a node here. There is a physical or virtual machine there. We have installed Elasticsearch there and have created index. Here is the index. Suppose this is an index, and inside that index, Elasticsearch does not keep those documents as a chunk. Suppose here we have a 100,000 document. Instead of keeping all those items directly into that index as a chunk, what does Elasticsearch do? Elasticsearch create another component that is called shard. It divides the index into number of shard. Here we have divided our index in 4 shard, and this number of shard can be defined when you are creating index. It may be 1, 2, 3, 4, whatever the number of shard you want, and each and every shard will have same property, exactly same as the index have, only the shard will contain less number of documents. Here we have 100,000 documents and we have 4 shards there, so each and every shard will have 25,000 documents. So these shards are distributed among different nodes when we are in a cluster, and we will see about this sharding and distribution of shards later when we will be discussing about shards more in detail. So these are the major components of Elasticsearch. Now let us see the Elasticsearch architecture. That is how all of these nodes are interrelated and what is their position in the architecture. Okay, suppose we have this cluster here. This rounded rectangle represents our cluster, and in a cluster there can be multiple nodes there. Here we have 3 nodes, and in a node there can be multiple indexes. Here we have books index, hotels index, and inside our index there can be multiple shard, and in the shard there remains the documents. And this is how all of these components are interrelated. Now in our next video we will see the installation of Elasticsearch, and we'll have some hands-on experience by putting data into Elasticsearch and making queries, etc. Thank you for watching.